Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. Today my group will be presenting about volumetric analysis. Hope you guys will enjoy the video. Hi, my name is Inshira binti Muhammad Razak.
Assalamualaikum and hi, my name is Julia Hannah binti Muhammad Syahri.
Assalamualaikum and hi, my name is Alidanisha binti Khairu Daniel.
Hi, my name is Adila Najiha binti Ahmad Asri.
So now I'm going to start with the first part of our slide, which is introduction. Volumetric analysis is a quantitative analytical method used to determine the concentration of a known substance in a solution. This is done by adding a known amount of reagent with a known concentration until a chemical reaction is complete. It is commonly known as titration or titrimetric analysis. In this process, precise volumes of solution are measured using laboratory glassware like pipettes, burettes, and volumetric flasks. This method plays a key role in chemistry because it allows for accurate and reliable determination of substance concentration in various industry and scientific fields.
Now, we're gonna go to the type of titration. Type of titration, we have three types. First is a simple titration, second is a back titration, third is a double titration. First of all, is a simple titration. Simple titration is to determine the concentration of unknown solution using the concentration of another known solution. Example for simple titration is acid-base, redox, precipitation, and complexisometry. Next is a back titration. Back titration determines the concentration of an analyte by reacting it with the known amount of excess reagent, whereas a direct titration examines the concentration of an unknown chemical directly. Excess reagents are not added in back titration. And the third one is a double titration. Double titration is to determine the amount of substance present in the form of solution with another solution. Gilson's titration method for estimating the concentration of argometallic compound in the hydrocarbon solvent is also known as a double titration.
And now I'm going to be explaining about the application of volumetric analysis. Volumetric analysis has a wide range of application across different industries. First, in pharmaceuticals, it is used to determine the purity and concentration of drugs. For example, titration is used to check the acetyl salicylic acid content in aspirin. Second, in the food industry, it ensures food product meet safety and quality standard. It helps measure acidity in vinegar or vitamin C levels in juice, such as through citric acid titration in soft drink. The third one in environmental science. Volumetric analysis is used to test water quality by detecting acidity, pollutant, and heavy metals. A common example is measuring dissolved oxygen using redox titration. And lastly, in industrial process, it helps control chemical concentration during manufacturing. It's widely used in industry like textiles, paints, and chemicals. For example, monitoring acidity in dye bath.
There are two objectives in this experiment. First one is to develop a simple potentiometric methods for the determination of citric acid concentration in wines and wine material. The second one is to determine the method's accuracy in measuring citric acid concentration ranging from 0.1 to 3.5 g per L, even in the presence of the higher concentration of other organic acid such as tartaric, acetic, malic, succinic, and oxalic acid. For the apparatus in this experiment, we use 50 ml beaker, graduated pipette, magnetic steering bar, copper electrode, silver chloride electrode, voltmeter, burette, and measuring cylinder. For chemicals, we use citric acid test solution, sodium hydroxide solution, phenolphthalein indicator, borate buffer, copper to sulfate solution, and twice distilled water.
Now I'm going to be explaining about the procedure of this experiment. So first, a 0.1 to 0.2 ml of the citric acid solution was placed in a 50 ml beaker. a 1 molar sodium hydroxide solution was added until the color of phenolphthalein appeared. Then, 2 ml of borate buffer solution was introduced and twice distilled water was added to a total volume of 10 milliliters. The beaker was placed on a magnetic stirrer, a copper and a silver chloride electrodes were immersed, and the titration with a 0.02 molar copper sulfate solution was carried out at a constant stirring. The titrant was added in 0.02 milliliter portions until a sharp change in the potential was observed. Lastly, after the addition of each portion of the titrant, the value of the potential was recorded. In total, 4 to 5 values were recorded both before and after the potential jump. These are the precaution steps that we can take before and during the titration. So first, always wash the glasswares with distilled water and completely dry them before use. Second, always rinse the burette thoroughly with the solution, which is the titrant, that will be used in it. Third, use a sliding double burette clamp. For an accurate reading, it is simple to go under the burette and raise or lower it to eye level. 4. Make sure the stop cock is closed. Always place a container beneath the burette before filling it. Next, do always use a small funnel to fill in the solution into the burette. Other than that, ensure there is no leakage from the burette during the titration. And lastly, before titrating the solution, remove any air gaps from the burette. Make sure the burette's nozzle is also filled with the solution.
I'll be explaining about the data collected and also the analysis. This table shows the volumes of solution 0.1 sodium hydroxide and 0.2 copper sulfate used for the titration of different volumes of 0.3 solutions of citric acid. As we can see, the volume of citric acid used is starting from 0.1 until 0.8, so the value is different. So the volume of sodium hydroxide used and also the copper sulfate used in this experiment are different. As you guys can see, from the 0.1 volume of citric acid, 0.8 sodium hydroxide is being used and 0.1537 copper sulfate are used. Next, we move to the calculation part. For neutralization of citric acid, first and foremost, we have to write the balanced chemical equation. The chemical equation is C6H8O7 react with 3 mol of NaOH will produce Na3C6H5O7 with 3 mol of H2O. Second is to find the molar ratio. 1 mol of C6H8O7 will require 3 mol of NaOH. And third is to find the molarity of sodium hydroxide by the value given and also the molar ratio that we get. So at 0.1 ml C6H8O7, 0.8 ml was used. So we can find the mole of NaOH first, which is M times V, and 0.1 mole per L we will time with 0.008 liter. We must convert the unit to liter first, and then we will get the mole of NaOH is 0.00008 mole. Step number 4 is to find the concentrations of C6H8O7. So C is equal to 0.080 millimole. We divide with 3 times 0.0001 liter, and we'll get the concentration is equal to 0.267 mole per L. Next, we will find the concentration of citric acid that react with the CuSO4. We will use the same step as before. So first, we find the molar ratio, which is the 1 mole of citric acid require 1 mole of copper sulfate. And then, we proceed to find the molarity of copper sulfate. At 0.1 ml citric acid, 0.1537 ml was used. So, at this point, we can find the mole of CuSO4 by multiplying, which is M times V, equal to 0 0.20 mol per L times with 0.0001537 liter. So we get the mole of CuSO4 as shown in the slide. This table shows the moles of sodium hydroxide and copper sulfate and calculated concentration of citric acid based on the titration data. Since the volume of citric acid that we use in this volume are different, so the concentration that we get for each volume are different. So as you guys can see, for the first column is the column for mole of sodium hydroxide and the second column is the column for mole of copper sulfate. This value we can get it from the calculation that we did before. From the molar ratio, we can find the mole of NaOH and also the CuSO4. So for the third column and for the fourth column is the concentration value for the citric acid for sodium hydroxide and also the concentration value of citric acid for the copper sulfates. So for the concentration, we also get it from the calculation that we did before with the same step. Therefore, the experiment successfully determined the concentration of citric acid using sodium hydroxide and copper sulfate titrations. Results shown consistent citric acid concentration around 0.3 mol with a confirmed 1:1 molar ratio between Cu2 plus and citrate ions. This demonstrates the accuracy of both neutralization and complete symmetry titration methods for analyzing citric acid.
In conclusion, volumetric analysis is a fundamental technique that used in analytical chemistry. This method is valued for its accuracy, simplicity, and cost-effectiveness, making it essential in laboratory settings, industry, environmental settings, and also pharmaceuticals. In the future, it is hoped that this method can be continued practiced, especially for students, or to strengthen proficiency and prepare them for professionals or real-world tasks.
That's all from our group. Thank you for watching.